You're looking at a university lab that lives in a van. It drives around California, sampling air pollution every second, street by street. A bit like Google Street View, but for chemicals. But whatever happens, it can't turn off. Not for lunch, not overnight, not ever. So the whole lab runs 24/7 on a Victron Energy system built in the back. We're in Benicia, California, with the University of California, Berkeley's Mobile Air Pollution Laboratory. Sam's the scientist running the project, Adam's the installer and a long-time Victron distributor, who had to build a system that behaves more like a data centre than an RV.
What we do is we measure hundreds of different chemical species in the atmosphere that are related to air pollution emissions.
We started talking about battery capacity to have enough power to create the AC power for its components. Victron is the primary system that we use for inverters, battery monitors, DC to DC chargers, solar controllers.
The science is simple to explain. Pull air in, measure what's in it, publish the data. The kit inside, however, is not so simple.
This is what's known as a proton transfer reaction mass spectrometer. And this measures hundreds of different volatile organic compounds. That's VOCs. And that is, things such as ethanol and benzene, acetone, all of these chemical species that you might find in the atmosphere. This is probably worth about $800,000.
$800,000 of kit, mounted in a van, and it has to work even when driving over potholes. So everything is shock mounted, calibrated constantly, and kept at a stable temperature. The van gets called into communities with concerns, smells, smoke and industrial areas.
We're primarily a data collection platform where we will measure in these different areas and then we will make the data publicly available. We can draw some conclusions to what we think might be the key sources in an area, but primarily we're a data collection platform. It's important to note that we're not a regulatory agency, and so we're not trying to catch all of these different industries and sources out. We're really just collecting data to try and improve our understanding of air pollution and give the communities some information that they can then use and follow up on if they desire.
Now the constraint that makes this build different: the lab can't tolerate unplanned shutdowns.
We have a lot of instrumentation in the back that we need to keep running 24/7, and because we have all this kit running and generating heat, the thermal load is pretty high inside, and so we have to have the air conditioning running 24/7 as well. Right? And that amounts to about 3 kilowatts of continuous energy that we need. What's essential is that we don't get any sudden power outages. A lot of this equipment operates at very high vacuum, and for that you need the pumps running continuously.
Sensitive instruments with 3 kilowatts of load in a vehicle plus air conditioning continuously. That's not exactly a weekend camper system, that's a lab on wheels.
One unique thing about their system is that it's running all the time. So the first thing I thought of was, well, okay, we need solar. But there's no solar because there's measuring instruments on the roof, and they have a high output second alternator. And so we started going through the parameters of what he needed to do.
Adam's background is RVs, vans and trailers, but this job flipped the usual assumptions. No solar panels on the roof, as that area is busy with sampling hardware. Instead, the van charges while it drives, then recharges on shore power when it's parked back at the campus.
So we decided on 2 3 kVA MultiPlus inverters, 50 amp shore power to recharge it.
With that, we can recharge the batteries and keep all of the instrumentation running continuously as well.
It's being used to collect information during the day, and then it's recharging overnight. The air conditioner runs 24/7, keeping it all cool constantly. So there's a little bit of unique requirements, but we went back and forth, worked out what needed to be done. It's really managing the power from the alternator and looking at the batteries at the same time. The system has a Lynx distributor with a Lynx shunt, but we also have a separate shunt that's tied into the wake speed, so it's tracking it all by itself and giving us that data through the 712 into the Cerbo system so we can monitor it.
The headline, Alternator charging, a big battle-born battery bank, 2 MultiPlus-II 3 kVA inverter chargers working in parallel to provide sine wave for clean AC power, and a Cerbo GX and VRM monitoring so they can see what's happening before anything becomes a problem. Adam said something early on that's worth keeping in mind. Victron can be intimidating to install because the system expects you to do it properly.
So my business started out mostly doing restoration work on old vintage trailers from the 1940s through the 1970s. And then I started working on all the RVs. And then I saw the opportunity to get into solar. That was about 10, 12 years ago. And quite honestly, I was nervous to use Victron systems because it was very complicated, very specifically needed to be installed following very clear instructions. But after a few installations, I realized, okay, it's just the same things repeated with a little bit of variations with the different battery types, different application. And then I saw the real power of Victron, of how easily it adapts to everything. A little bit complicated to install, but then it makes it super simple for the end user to just see their power coming in, being used, when they're going to run out of power. It's an incredible system.
Did you know Victron Energy has a really useful document called Wiring Unlimited? It's written by one of our highly experienced engineers, and it explains electrical systems, how to wire, and as Sam highlighted, the importance of getting it right. There is a link to the free PDF download in the description. That's the point here. This isn't just cool tech. This is critical engineering in a van, and the outcome of the results can change people's lives. A mobile lab with $800,000 of instruments running non-stop, doing 1-second measurements, and the power system just sits there doing its job.
At the start, we had a few teething problems with, we had an alternator belt broke. That was kind of unlucky. I think we got one of the fuses wrong, and so we had a power cut that way. But since we've navigated those initial issues, we've had the system running 24/7, and it's been super smooth.
We're very proud of the system that we built for the University of California, Berkeley. It's impressive that it's going all over and making a difference, and probably an even bigger difference in time.
This van doesn't argue cases. It doesn't point fingers. It measures what's in the air accurately and keeps running. And behind all the science, the quiet enabler is the Victron Energy power system. Another system that must remain on, even if there are many meters of snow outside and is impossible to get to, is this hotel on an Austrian mountaintop.